Okay, last four identities for this worksheet. This is solving or proving identities part 3. So what we want to do is we want to prove that sine squared theta over 1 plus cosine theta is equal to 1 minus cosine theta. Okay, and one of the things that we're going to work on right away is, we're going to freeze this side, and we're going to remember that Pythagorean's identity says that sine squared plus cosine squared is equal to 1. And then solving for any one of these things, what I'm going to do is I'm going to solve for that sine squared theta. So I'm going to subtract cosine squared theta from both sides, leaving me sine squared theta is equal to 1 minus cosine squared theta. Okay? Again, one of the alternate identities we can use for sine squared. So what I'm going to do now is for this sine squared, which is right there, I'm going to plug in this 1 minus cosine squared theta. So 1 minus cosine squared theta over 1 plus cosine theta is equal to 1 minus cosine theta. Okay? Well, again, recognizing that this is the difference of two perfect squares, this is going to factor into 1 plus cosine theta times 1 minus cosine theta. All that's over 1 plus cosine theta. I'm going to put that in parentheses. And all that's supposed to equal 1 minus cosine theta. You can see that these two will cancel, leaving me with 1 minus cosine theta is equal to 1 minus cosine theta, and we are done. Moving over to number 20. Okay, I don't think I have to make any adjustments here. Let me put the light on, maybe it makes it look a little bit better. Not really. But here we go. I'm going to freeze this side, and I'm going to work with the other side. When you're dealing with one term and two terms, your best bet is to work with the two terms. So this is the first time I'm freezing that left-hand side, so it's kind of good practice. That's going to equal, well, tangent I'm going to change to sine theta over cosine theta, and cotangent is cosine theta over sine theta. Okay? Now once again, this multiplication actually acts as one term. The addition gives me two terms. So what my next step is going to be is trying to get the right-hand side now to become one term. So my common denominator will be cosine theta times sine theta. I multiply cosine by sine, doing the same thing to the top. I get sine squared theta. I multiplied sine by cosine to get that common denominator, do the same thing to its numerator. We get cosine squared theta. Now we have an identity. This time we're not going to plug in for 1. We're actually going to plug 1 in for that. So I have secant theta times cosecant theta is equal to 1 over cosine theta sine theta. Now I'm going to take this fraction and split it up into two separate fractions. So we have secant theta cosecant theta, and I'm going to split this up into 1 over cosine theta times 1 over sine theta. All I did was split up that product, same fraction as that if you multiply it together. And then you can see that you have secant theta cosecant theta is equal to, well, that becomes secant theta, that becomes cosecant theta, and we proved it. Alright, moving down to the bottom here. Get it all lined up. I think we're good. Same thing here. I have nothing to substitute in for. So what I'm going to do is I'm going to make my common denominator, obviously we're going to freeze the 1. I'm going to make my common denominator on the left-hand side be 1 plus cosine theta. This cosine was over 1, which means now it's over 1 plus cosine theta, so I have to take that cosine theta and multiply it by 1 plus cosine theta. Plus, this doesn't change at all because the denominator stays the same. There's my sine squared theta, and that's supposed to equal 1. Distributing the cosine through, cosine times 1, cosine theta. Cosine times cosine, cosine squared theta, plus sine squared theta. All that's over 1 minus cosine, or 1 plus, my fault, cosine theta. And that's supposed to equal 1. And as you can see here, once again we have cosine squared plus sine squared. That's the Pythagorean identity. We can plug 1 in for that, so I get cosine theta plus 1 over 1 plus cosine theta. And these are the same thing. And when you divide something by itself, you get 1. We're proven. I guess my next step here, or my first step here, would be changing sines and cosines, or changing things to sines and cosines. I'll freeze that 1. Secant is 1 over cosine, and that's divided by cosine over 1. Minus tangent is going to be, tangent squared is going to be sine squared over cosine squared, and that needs to be 1. When I state change flip this, I'm going to wind up getting 1 over cosine squared theta, if I do that properly, minus sine squared theta over cosine squared theta, and all that's supposed to equal 1. Notice we do have common denominators, so I'm going to put it all together. So we get 1 minus sine squared theta over cosine squared theta is equal to 1. And again, this is another alternate to the Pythagorean identity. This becomes cosine squared theta. So if I plug cosine squared theta in for that numerator, bring it over here, 1 equals 1, and we're done. And that concludes that worksheet on proving identities.